Ideas are crowdsourced.
Yes.
Set it up. It is 7 o'clock, so we are going to get started here. Hi, everybody. My name is Will Buck.
I will.
Along with some of the other fine folks here at Virtual, we're putting on this Angular event first Wednesday of every month. I did actually get some offers to host the meetup in a larger space so that we do not have the reoccurring RSVPs problem. So I put a poll up on the site, the meetup site. There's talk of a place in downtown Minneapolis that could host and has a larger space. Talk of a place out in Edina. If you have a bigger space and want to talk to me about potentially hosting there, I am interested in talking to you, so come find me. But otherwise, you know, most of the people here are cool doing it here. How many people would stop coming if it were in a different spot? Be honest. It depends on the spot. Okay, so half a dozen or so. Okay, that's good to know. Thank you.
I won't go if I have to pay for parking.
All right, fair. That is the deciding factor. So like I said, thanks to Virtual for sponsoring the space. For those who don't know what we do here, it's basically like an online doctor's office. So if you get sick with something you think you don't have to see somebody for, go to our website and we can probably treat you. And thanks to Scott, who is our presenter today, as he is sponsoring the food and beer for now and the next couple months, and we'll see from there. So big ups to Scott. So usually how we kick things off is we do any kind of community announcements people want to say, looking for work or hiring people. So let's start with that. Anybody looking for work? Nobody. Ray, Angela. Anybody looking for workers that wants to make an announcement? We are not currently hiring, but I'm always interested in hearing from people who are interested in working here. So feel free to meet a best friend. We do not have a presenter for next month. So if you are interested in presenting, there is a spot on the message board for you to put in there or just message me, and we will get you scheduled. Otherwise, our kind of go-to thing if we don't have a speaker is to do a hackathon type thing. So that's all. I didn't get to go to the only one we did, but I heard it went super well. So it's always an option. Any other announcements people have? Oh, thank you, Joel. So you might notice that I'm sporting some new wares. Up on redbubble.com, you can buy a shirt like this one or whatever color, and there's another logo size that's like this big. So if you want to support the group, I put 20% markup on that stuff, and that's just going to fund me pizza and stuff in case we don't have a sponsor. So grab a shirt. This one's super comfy. This is the organic t-shirt variety that we have over there. Okay, did anyone want to come up and spiel with some lightning talks?
I was going to do the little announcement for Startup Weekend. If anybody cares.
Yeah.
So, for those of you who don't know, coming up next on the 12th, 13th, and 14th is Startup Weekend, but there's actually a whole Startup Week. So Startup, TwinCityStartupWeek.com is the URL, and it will show you all of the events. Hopefully I can scroll there. All the events that are going on, Beta MN, Minnesota Cup, whatever. So you can go to all that, but the main event is Startup Weekend, 12th, 13th, and 14th on Friday night. There's about 125 to 150 people who show up. Everybody who's got a startup idea pitches their idea. They get 1 minute to pitch. The community that's there votes on the best ideas, and then the top 10 or whatever it is break off and work on those ideas. You kind of form teams and work through it for the weekend. Then on Saturday evening, you pitch, and there's press there, and VC and things like that. And on Sunday evening? On Sunday, sorry. On Sunday, you pitch at the end of the event. So it's really cool, a lot of fun, a lot of new technology, really cool to see all the stuff that people think of, all the crazy ideas are fun to do. And it's really cheap. I can't remember, I don't know what the tickets are right now, but it's basically just to cover the cost of your food because they feed you the whole weekend too. It's at the U of M campus, but check it out. It's just, I'm not really involved in it, but I've attended a bunch of them and they're super fun. So I encourage you to check them out.
Awesome. And there's a mini demo happening as a part of that as well. And that's, what is it, Thursday, Tuesday?
Probably why today. Crushed it.
Thanks, Scott.
You're welcome.
There's a boot camp on the 11th. So just if anybody cares, there's a boot camp on how to win on the 11th, which is run by myself and Scott Davis, who won the first one and started a company called Conquer after that. And then the mini demo, I think, is, yeah, so mini demo's on this Thursday.
Thursday also. Okay. Sweet.
Cool.
Yes, come on up. Yeah, here's Scott. I'm going to move you down here.
Yeah.
Oh, well, that works too.
All right. So my name is Jim Cummins. I am a developer at FizzDapp. They make educational software for EMS and paramedic students at different programs around the country. And I wore my Ionic t-shirt today because we are writing an Ionic application. Apparently there was a talk here, I guess.
In April, yep.
April.
Core committers, the core team was here to talk about it.
Cool. Yeah, so we're pretty small. We have, I think, 16 people and like 8 devs. So we don't have enough people to do both an Android and an iOS app, and we just kind of were looking for something cool to try out. We didn't have an app yet, so we decided to come up with something in Ionic to see how it went. So this is. A lot of what I've been working on is authentication, which is pretty tricky. So basically, we're just using a lot of the really, if you use Ionic, like the default styles. We convinced our designer not to change a lot, so it's easy for us, which I would highly recommend if you can do that early. There's a few core things that we changed. If you're familiar with Ionic, like we had really small changes to this, which is the Ion action sheet. And I guess my only question, and I'm really interested to hear what you do in this case, is I'll show this later, but basically we're decorating. So if you're familiar with decorating a provider, that's what we're doing with this, just to swap out the template so that the core functionality and how you use it, how you call it, all remains the same, but the template changes. So I'll show that. So this is logging in as a student, really simple. This is not a great code. It's a break. All right, so yeah, they get a shift list. On here we don't have an address for this location, but on your phone this opens your Maps application. And then so basically we're releasing that this is kind of a beta. One word of advice if you do an Ionic application is don't do a beta because Apple will reject you. And so we felt we're like one of the 2% of apps that got rejected for that. So don't put beta in there; they will reject you. It is if you have beta, trial, or it's like anywhere at all, they will. It's in their terms, but it's very. It's unfortunate because we're going to release the same app. We're just not telling our users it's beta. So I don't. Yeah, take that as you will. But we. So we basically were this app we're running in Cordova. So we get iOS and Android out of the same code base. So we can have instructors or students log in here. If the student logs in, they get their shift list. So this tells them all the shifts they're assigned on in the past. And then if they're an instructor, they actually get to pick from their list of students. I won't show that. And then they can get the same information but as a student. But one of the questions I guess I have, and I'm curious, I would love to talk to you about this, is we are doing something which feels a little weird. It's the decorating. So we're decorating here. Can anyone see the banner? This could be bigger. Yeah. Okay. Is that any better? Yeah. I know it's a lot of text. Mm-hmm. So really what I'm kind of considering is here, essentially Ionic provides you with a bunch of stuff, and my question is this the right way to do this? We're overriding the directives template property, and I don't know if this is the way to do it, but it's the easiest. It lets our new devs that are coming on the project use the Ion action sheet just the same way they normally would. If they go to the Ionic docs, they can do all this. They can use Ionic just how they would. They don't need to use like FizzDApp action sheet or anything. But it does swap out because we needed to add some functionality in here and override some other classes. So we use this. It feels okay, I guess, but I'm not sure.
Just one quick thing, I would probably put a paper do that.
Okay.
Separate file.
Sure.
That would be
Cool.
That's, I thought it
Okay. Okay.
I found if you're supplementing a directive, like you're like maybe not modifying its behavior, but like enhancing its behavior, they just make another directive the same thing. So it looks like you're actually changing.
We are, yeah.
So that would,
that's what writers are supposed to do.
Okay. Yeah, this is all a little new to me, so I did this because I found it on like Stack Overflow. Sorry. Whatever. So thank you.
Exactly.
Yeah, that's all I have. Is there any questions? No? Thank you.
Anybody else wanted to come up, show off something they're working on, something cool, ask a question? Nope. Okay. We'll give the floor to Scott then. Go.
I'm not going to bother presenting since I won't be spending much time here. Hello everyone, I'm Scott Silvi. As he said, I'm the sponsor of the Angular MN Meetup. I also own a consulting company in town. No one's looking for work, so I won't waste any of your time telling you I'm hired. So what we're going to talk about today is we're going to be building the Angular Digest and launch cycle from the ground up. And one thing I want to stress is this is not a like side-by-side comparison of what you'll see in Angular source code. What we're really opting for is clarity and intent. So understanding what makes Angular Angular and leaving the things that don't really make a difference in Angular. I don't want to say leaving them out, but you'll notice right away I'm using Lodash for some utility functions rather than building Angular values, for example. There's really no sense if Lodash can do it for me. And the other thing is this is actually based on chapter 1 of the book called Build Your Angular JS. It's a fantastic resource if you want to actually get into the depths of Angular. So it's currently in active development right now. He's currently rebuilding file service and the directives, and that's kind of get through these once every couple of weeks, so we'll have a new chapter. So I just found it's a really cool way to kind of dive in and you know, you're not building a framework that you can then take and use in production. You're really more building the framework that you use in production to understand more about the intricacies. And you'll see I have a best practices slide that I'll reference a few times. And a lot of these aren't necessarily things that I learned while doing this, but there may be things that I knew that I shouldn't do, but I didn't really understand why. And so that was probably the biggest value add in going through this thus far. All right. So as I said, I'm going to be live coding, scope, watch, apply, digest. Ultimately, we'll end up with 76 or so lines of code. Not all that much. Certainly doesn't represent everything that's in the Angular scope, watch, digest cycle. But given 50 minutes of time, I'm not going to be able to implement everything. So it's really just to give you kind of an introduction to it, and hopefully get you to take a look at this book, which, as I said, is in active development. I've been contributing to errata and suggestions frequently, and hopefully more people will. So I think this is a pretty awesome resource. So for those of you that maybe aren't familiar, the digest cycle is really responsible for one of the main core features of Angular, which is the two-way data binding that you get. And this happens implicitly when you use things like ngModel under the hood. That's using watchers and the digest cycle. And explicitly if you do things like scope.$watch and create your own watchers. So I think I'll probably just get right into it. So I've taken the liberty of setting up a very simple development environment. I will be test driving all of this. He does test drive in the book, and part of the reason I think it's a really good idea is, number one, it just gives us a place, a sandbox to kind of play with the code that we're writing. And then it also, just if you've never done TDD, the philosophy is kind of red-green, refactor. Red means you write a test fails, red code passes the test, and then you refactor. And what's really nice about that is if you try to go just right now and look at the Angular source code and you look at the scope file, there's a lot going on in there, and there's a lot of edge cases and a lot of things that that are being done for performance. And as I said at the beginning, it's for me doing this. What I've loved about this book is that it kind of exposes things more gradually. You start with, literally, we're going to start with the scope.js. That's what we're starting with. Yeah, I will absolutely.
Perfect.
So scope.js, more or less empty. I'll talk about a bunch of this in a minute. This is the one that's got too. All right. So we start with this, and we'll end up with at least the core of what I'm talking about. And so we just kind of build on what we're going to start with, and introduce more advanced topics later on. So one of the things you might notice right away, actually, in this first test. That's what you get for having to work on Windows and getting your key bindings backwards. So we're doing up the scope right on line 10 there. And anyone's worked in Angular is going to say, well, I've never done that before. So this is an example of kind of how we build on it. Scope itself is actually wrapped in a provider injected into the core ng module that's created when you bootstrap the app. And it's injected as root scope, which we're all familiar with, and all child scopes inherit from that parent scope. I haven't built the provider yet because we got, as we saw, this is it. There's no provider, there's no Angular module system, there's no dependency injection system. So we're starting with kind of the basic, and we'll build up from there. So the first thing is Angular scopes. They are just basic JavaScript objects or functions, whatever you want to call them. They use standard prototypical inheritance, which means they have all of the features or bugs that JavaScript has. So the primary uses that we see scope, they're used as the primary mechanism for communication or data sharing between controllers and views. They're also used for sharing data between disparate components of your application, like different controllers, for example, usually via services, or via events, the event bus, which is broadcasting and listening for events. And then lastly, watching for changes in data and then acting on those changes, and that's the watch digest cycle that we'll talk about and implement. All right, so we've got our first test, and hopefully I have. All right, so we talked about red-green refactor. There's our red. The test is running right now, and it's failing because scope is not a function. Right now, scope is just nothing. So to make that test pass and to prove that the scope is indeed just a function, oh, Tino, I told you. Now our test passes. So at its core, that's what scope is. It's just a simple JavaScript object, and then we are going to add a whole bunch of features and functionality to that. That in this case will implement the digest cycle and dirty checking and all that. So I've also gone ahead and written most of at least the stubs for all the tests so that I don't have to waste time doing that. I guess this will be the fastest primer to test framework that you've ever seen. But if you look at what we see here, we have a big header scope, and then we have smaller text, we'll load that up a little bit. Can be constructed using an object, and if we click on it, we actually get to see the test that was run. So that comes from this describe block that gives us the header, and then the it block. An it block is just it's a block of arbitrary JavaScript that you can execute and then assert or run tests against. And so the first two lines are just creating a new scope. We're attaching a property to scope and assigning a value of 1 to it. And then all we're doing is we're using Chai here for Chai's expect. Chai is a testing assertion framework. We're saying we expect that scope.a property is going to equal 1. And so if I change this to whatever, our test is going to fail and say expected 1 to equal 13. So that's the brief primer into testing. And what you'll see throughout this talk is I'm going to be writing a bunch of code, and I'm going to be creating assertions to evaluate the code as what we expect.
We're talking about Chai. Why use Jasmine versus Chai?
Well, Mocha and Chai is what we use at work. So, well, we were using Jasmine, and then we switched to Mocha, and now we're back in Jasmine. It's a whole different story. I guess the other thing, too, is the one other kind of piece of test framework code. This is before each block, so you'll see down below in my digest, I've got a whole bunch of code, a whole bunch of if blocks. Before each just runs before each of them, and in this case, I've got a variable called scope. I'm assigning an instance of our scope function or object to that variable, and then I'm attaching a model to the scope as an empty object. And this is just simple build-up code, so that I don't need to do it inside of every test and don't have like artifacts from previous tests that are hanging out on my scope. And a shout out to the dot problem that Will and I talked about. If you ever give a talk on Angular, please don't attach properties to the scope directly. Sometimes the dot problem, it's not actually in Angular, although it's been popularized by video and Egghead.io. It has to do with JavaScript inheritance and something called attribute shadowing. I won't get into it, but if you don't know about the dot problem, probably look it up. It can be the source of tremendously irritating bugs that are solved by having not treating your scope as your model, but attaching a model to scope. All right, so let me get my notes going here. All right, so what I'm going to do is I'm actually going to implement the $digest and $watch functions. And I think I'll write the test and then kind of go back and explain it, especially for this one, because without a little bit of reference, I think I could just talk and you guys may or may not be able to keep up with what I'm saying since I'm trying to move kind of fast, not because I don't think you're competent. So what I'm doing here is I've got an if block that, because it's nested under the digest, I'm saying the digest should call the listener function of a watch on first digest. So I'll explain the assignments by and everything that's going on in a second. All right, so first of all, the watch function is just a function that returns a static string. In this case, a listener function, I am using something called sign-in, which is another kind of test, it's a mock and spy framework. And really all this does is this creates a function and an object that allows me to do things like say, expect listener function dot call to be true, or I could say listener function dot called with or dot call count. and just basically assert things against this function being called. So the watch, dollar watch, I've got a slide for that. I created all these really cool transitions, but I'm not going to do it. Like I said, I don't want to. I'm not going to spend a lot of time in the presentation. But a watch function, I'm just going to read that. A watcher is something that is notified when a change occurs in the scope. So you create a watcher by providing two functions to watch. And so I'll actually just toggle back here. So you have two functions that pass into the dollar watch. The first is a watch function. The second is a listener function. The watch function specifies a piece of data that you want to observe, and the listener function is the callback that gets fired when that data changes. So you guys might be, are probably more used to calling a watch like this. Yep, as an expression. A listener function. So this is actually handled by the Angular $parse service, which is a really neat, actually. It's a lexical analytics language kind of baked into the Angular core that will take any expression you put in there and convert it to objects, functions, arrays, etc. Since we're on Angular day one, we haven't built that service yet, so we're going to start with the base implementation, which is the watch function. And so what this will do is it'll watch on the return value of whatever function we pass in, which in this case is a static string. Since this never changes, the watch won't get fired on subsequent digest cycles. So digest cycle, what is that? Dollar digest, that's where all the dirty checking occurs. So digest checks the value of this return value in the watcher function, and then if that value has changed since the last time it ran, it'll call the listener function. That's the generic pitch on what the digest is, but it is one thing that you'll find as we're running through a test is that when you run digest, the watch function will always be called once, and the listener function will. So we've got a test. Let's hit that. We'll show you here it's actually undefined as not a function because watch doesn't exist. Let's go ahead and create the watch and digest functions. So the first thing we're going to do is we're going to create a watchers array on the scope. And one thing to note here, the $sign or $$ prefix marks a variable as internal to Angular, and you should really never access it from the app code. That is actually one of my best practices. That comes with a caveat, though, of so we already talked about one, don't hang properties directly on the scope. And that's number two. There are some weird bugs or things that you sometimes have to do. Off the top of my head, I can think of one we had to do with, I think, route. To get the last route in a situation where we couldn't use route change success or location change success, whatever that is. So as with all best practices, take with a grain of salt. Sometimes they apply to what you're doing, sometimes they don't. But so now we've got an array, and this is the array ultimately that our digest function will iterate over. So we'll start with the watch, and that takes the watch function and the listener function, and some of the astute Angular developers out there might say, oh, well, actually watch takes three. This goes back to that concept of kind of more the agile approach. We'll actually be implementing the deep watch quality check later on today. We're just going to create a simple object based on what's getting passed in. And then we're just going to push that to the watch to the right. So that's the core. Oh, thanks. Yeah, feel free. Doing this is not the easiest thing in the world. So if I miss anything,
maybe try putting that on your screen down there. Or do you have it on the screen?
I actually have.
Oh, your code.
Yeah,
oh,
all my code, all the things I want to say, everything's right here. So it's.
Yeah, I was gonna say.
All right, not yet. All right, so here's the first time where we're not using Angular. This is a very promiscuous digest. It calls listener all the time, which is not not necessarily what we want. So, as we talked about, the main purpose of the digest is to do dirty checking and call the callback to the listener function if a watch is dirty. So we'll go ahead and, first of all, actually, I should pass our test at least. Yay. All right. So whether we, as a quick aside before we actually implement dirty checking, whether you're using watch functions like we are here, or expressions that I talked about a moment ago, watches are almost always based on scope properties. So one of the things we have to do to kind of get things rolling is to make sure scope is always passed to the watch function. So that's our next test here. And we're going to see another time and spy. I think we got one more stub, but this is the second to last use of things that are English. All right, so we're going to call watch again. We're going to run our digest. And we're going to expect that our watch function is called with scope. All this is saying is, right, we've got a spy again, which is just going to listen to whenever the watch function is executed. And in this case, this called with will just allow us to pass in the parameters that were passed into the watch function itself. In this case, we're going to assert that it's called the scope. So as usual, we're expecting false to be true because it wasn't actually called with scope yet. And so we're going to go ahead and cache the scope. We'll call our watch function. Nope. There you go. With our scope. And our test passes. All right, so we're a little closer, because now we're actually executing the watch function, which is supposed to determine whether or not we need to call the listener function. But we're not actually calling the listener function if the value changes. So that'll be our next test. So we're expecting that digest will call the listener function when the watch value changes. This one is a little bit more compelling and interesting for several reasons. So here we're actually seeing the full method signatures of the watch function and the listener function. So we're defining a watch. In this case, we're watching on scope.model at some value, which again, since I know a lot of people don't probably do function watching, this is the equivalent of that expression, returning this value. And then the listener function takes whatever the updated or new value is, whatever the previous value was, and then an instance of the scope or the instance of scope. In this case, all we're doing is incrementing a counter to say, hey, the listener function was called. And initially, we're expecting the counter to be 0 because we haven't digested yet, so there's no reason for this to run. I've used this a bunch of times, so. But now if we digest, we expect it to be once because the listener function currently is always called at least once. And so now we know this is going to get incremented one time. And if we digest again, now it should still only be 1 because the value hasn't changed. So the idea here is that the listener function should always be called once initially, and it'll only be called if the data has changed since the last digest. So now if we say scope.model.some value equals now b instead of a, we still expect it to be 1 because we haven't actually executed the digest. Now if we do digest, now we'll expect it to be 2. And so of course this is going to fail because we haven't implemented this yet, but cannot read property of model of undefined because scope doesn't exist. We haven't passed anything for a listener function yet. So I do want to actually, let me jump back here. I do want to highlight it. I just mentioned it, but the listener function is always called once, no matter what, at least once. And in fact, you'll find out later it's oftentimes called twice. And the reason that's important is if you have complex logic or blocking logic or anything in your listener functions, in a large application, you might have hundreds or potentially even thousands of watchers. So there'll be a best practice that I'll talk about how to kind of bypass the listener function always being called once. And when we get to the implementation of that, I'll talk about that best practice some more. But I did want to highlight it. All right. So we're going to now implement dirty checking in our digest. We set new value equal to the return value. So again, our watch function is going to return a value. And so we're going to set that return value to our new value. We're going to set our old value to watcher.last property. That doesn't exist yet. So this is the first time we've seen that, and we'll address that in just a moment. And then now for the simple, very, very simple implementation of dirty checking. If new value and old value are not equal, we do two things. One, the watcher.last equals the new value. Yep. And then two, now we're saying here, right, if our watcher is dirty, then we're going to go ahead and call the listener function. So this is where we're actually getting dirty checking for the first time. So I think if I did that right, yep, so now our test pass. So a few things to point out. I've worked with a few people who were concerned about attaching data to scopes and how the performance implication that might have in Angular. Aside from property lookups and things like that, there's no performance implication to attaching a ton of data to a scope because scopes aren't iterated by Angular, only watchers are. And then again, every watch is called during every digest. That's actually not again, that's new. In case that wasn't apparent from the for each, every watcher inside of the scope is iterated on every single digest. So one of the best practices, which is in my slide deck, I won't go through it, but I'm sure we'll post the slide somewhere, right? Well,
yeah, I can post them on Twitter and in the Meetup page, whatever.
So you really need to try and limit your watches and ensure the performance of any single individual watch doesn't slow down your app on every digest. And a lot of times you can use things like ng-change instead of a watcher to basically bypass the digest cycle and not add more and more watchers to your digest. I've worked on an app that we had like 3,500 different watches going at once. It was a big data app and presenting a lot of data on the screen. It was maybe slow, and that was one of the key reasons why. So I'm actually going to take a quick pause and see if there's any questions, and I'm kind of running through. Okay. This was really supposed to be more of a comedic act until I ran into time limitations, so I apologize for not having like funny memes or various other internet goodies for you.
Other cats.
Yeah, exactly. I hate cats. That's the only. I know. I'm very allergic to cats, so hopefully that at least that'll get beaten on my way out. All right. So I mean, if we take a step back here, 28 lines of code, we've implemented very simplistic, but we've implemented a dirty checking mechanism, which is pretty cool. One of the things that there's several things missing. Not the least of which is we're only doing reference dirty checking here, so we're not doing anything with object properties or arrays or anything like that. And we'll cover that in a little bit. But the next thing I'm going to touch on is, so the first time a watcher is executed, watcher.last is undefined. So what happens, and then we're doing a comparison here from new value to old value. What happens if the first legitimate value of new value is undefined? Our listener function will never get fired because of this equality check here. So we're going to jump over to our specs. We're just going to make sure our listener function gets called when the watch value, the first watch value is legitimately undefined. Something else. Tell me, man, you'd be rich. So this paradigm, you'll see this very common throughout the tests. We're just making sure listener function is called. You can digest, and then we're going to start. Expect. So something to note, scope that model with some value has never been visualized, so that's undefined. And so right now, we expect 0 to be 1 because the listener function is never called because both new value and old value are both undefined. So to pass this test, what we need to do is initialize the watcher.last property to something that we know can be absolutely unique at all times. And how Angular does it, which I think is actually pretty clever, is JavaScript functions are so-called reference values, so they're not considered equal to anything but themselves. And so how Angular handles this.
Is it NaN also that way too?
Yeah. Well, we're actually going to breeze through NaNs. If you have an NaN, you'll get to a digest iteration.
Oh, really?
Yeah, loops. It's never equal to itself. Yes. So we're just going to create a no-op here. Yeah, it's and we're just going to initialize our last property on our watcher to init watch val. And then, so ultimately, this is why we will always guarantee that your listener functions will always be called once, because new value will always be unequal to old value, since old value the first time you run will always be this init watch val function. So let's save that. Then so now our test is passing. Cool. So this is cool and this works, but there is one kind of side effect that we just implemented that we probably don't want. And that is right now, all value is being leaked out as this no-op, which doesn't really make a lot of sense and is pretty counterintuitive. So our next test is going to cover that scenario. And interestingly enough, how Angular chose to handle this is if this is the first time that you're iterating the digest or the watchers array, it actually calls the listener function with the new value assigned as the old value for the first time. And I'll talk about the best practice around that in a second. But I always found that to be particularly interesting. This falls under the category of I knew that this was going to be a best practice, I just didn't know why. So all I'm doing here is I'm watching on some value, and then I've got this old value given property, and I'm just going to assign whatever comes back from the listener function as old value to the old value given. So we'll digest. And then we're just going to assert that old value given is going to equal 1, 2, 3. I'll get to the best practice here in a second. So pass this test, which is currently failing. So you can see this is where we're bleeding up at an init watch val. It would be pretty confusing, I think, to most people if you're to run across that in your app without knowing why. So what we're going to do we're going to check to see if it's, so it is equal to itself, it's just not equal to another instance of itself, basically. So we're going to check to see if old value is equal to init watch val, and if it is, we're going to assign new val, and if not, we'll select stay old val. And it passes our test. So this is why the best practice, I've got it, this one I will pull up, it's a little more difficult to explain. So your listener function, which would be this guy. So this code in your app code where it says old value given equals old value, that should always be wrapped in either one of these two, where you're checking to see if new value is not equal to old value, then do the things you want to do, or you can just short circuit return if they're equal. That is, of course, unless you actually want your listener function code to fire once for no reason. I mean, I guess there probably could be reasons to do it. I don't know that I've ever come across one, but this is the reason why. Is we're passing new value and old value as the same, pointing to the same value the very first time you run through it. And so what ends up happening, right, is if you have 100 watchers in your app or 1,000 watchers, your listener function code is going to get executed 1,000 times unnecessarily. So that was another one where it was like, oh, I kind of knew that. I think it's even on Angular's best practices guide, but I never understood why. So it's kind of a cool thing to learn.
Do the directives use that to avoid single hit on like running that once and updating that?
No, at least I don't think so. I have to think about it, but my good answer is no. I guess one thing we'll cover, partly because the book covers it, partly because when I first wrote this, I couldn't think of any reason why you'd ever have a watcher that emits the listener function. The reason it's in the book is because you can do it, and so we need to support it. Originally, the only reason I could ever think of why you want a watch function that didn't have an action to perform if your data changed is if you just wanted to know when a digest was occurring. So I can see you doing it for maybe performance tuning. If things are just getting crazy, you could throw this in there and just see how many logs come out, see how many watcher functions fire. But then I thought of something a couple of days ago that maybe if you wanted to defer execution of some code until you knew a digest cycle had ran for some crazy reason, and you didn't want to use like eval async or some of the other options that are there, set timeout even, set the timeout service, I should say. That could be a reason why you do this, but I really don't know. So I'm actually just going to drop the code in, and has anyone ever done that? Create a watch function without a listener for any reason? Yeah. Okay, well, I'll just drop this in. Know that you can do it. And if you ever think of a reason, ping me on the Twitters, because I'm kind of curious about that. So right now, if we run this, it's going to fail, because it's trying to call a listener function that isn't defined. And so we can pass this test. I don't know what it is. It's like pandemic. All right, so we passed the test. Like I said, I'm not going to spend a lot of time on that. I don't think it's very compelling. So one of the other things that we can run up against, well, I guess let me take a quick step back, look at the code. One mouse over there. So we've added a little bit of logic into both our watch function and our digest function to handle some errors or kind of some edge cases. And we've got Ruby checking in. Well, one of the I don't want to say primary use cases, but maybe a common use case is if you have a listener function, and that listener function changes a property that's watched by something else. You get this kind of watch listener dependency, watch chain, whatever you want to call it. And currently, with this implementation, we're just iterating through the array once. And if a dependent function is registered first, and then it gets updated to the second function, that'll never fire. So basically what we want is we want a digest cycle that doesn't care what order they've been added to the array, but if there's dirty values, it'll digest. So pull some code from here as well, talk about it. So this is, it triggers chained watches, I should say, in the same digest. So we've got, I don't know if chain is a supermodel or just a model, but so we've got two watch functions. We'll start with this one actually down here. So in this one, we're watching on model.name, and if it changes, we're setting a new property called model.name upper, whatever the name is, uppercase. And then this name upper is in fact watched by this function up here. And this function then sets another property called initial. And so if we drop in a couple of digests. So in the first digest, we're expecting initial to be J, because that's Jane. And then if we change the name to Bob and digest again, we're expecting it to update to B. If we run this right now, it's going to fail because it doesn't know what scope that model.initial is. Interestingly, we change the order of these. It passes. And so,
All right, it passes.
moving on. I actually had a weird one where a test coverage report was failing because of one test. So we're just like, all right, so again, what we really want to mitigate is a situation where we order the digest or the watch, the watchers and the watchers, or the watch functions and the watchers array. Doesn't matter. And so here's where we're going to deviate again a little bit from Angular source. We're going to create a function, an internal function called digest once, which is going to be responsible for a single digest, and then we'll go back and create a digest function, which will have a wrapper around digest once. In the Angular source code, this is all nested in one huge, several nesting layers deep function called digest. But for clarity, we're going to break them out and make it a little easier to understand read. So we introduce this concept of dirty, and dirty is going to be set to true if at any time in iterating our watches array something is dirty. So basically the concept is not necessarily that this particular watch is dirty, but just that any watch in the cycle is dirty. And then we're going to return that. That is, and then we're going to redefine digest as a slimmer function with not much going on. And this has been something really interesting. I haven't used a do loop in JavaScript in a very long time. Angular does all over the place, and there's actually some really cool uses for it. Specifically, if you want to iterate through an array, you can do things like, whatever, the shift, shift.
Anytime you can move the bottom of the thing.
We'll set some. And anyway, you can shift items from an array, and you can do like, I don't know, whatever you want to do, but maybe it passes into a function or something, I don't know. But then just while, this is really good code. Something like that. Again, you're operating on something there. But that was, you actually do that in Angular at one point. I thought that was pretty cool. But anyway, we got a do loop, and we're going to say dirty equals this. So now we're going to call it digest once from here. We're just going to loop while dirty. So now what's going to happen here is the first time we run through a digest iteration on digest once, I shouldn't point. It's great for me, but maybe not for you guys. So the first time we iterate through, if any of our watchers are dirty, we set this flag, we return it, and the digest is going to fire itself again. So while this can be really cool if you have these concept of chained watchers, very quickly you could run into the 10 digest iterations reached aborting error if you've seen that before. So we'll talk about unstable digests and how to handle that in a second. But I think we've done enough now to pass our test. Yay.
I feel more comfortable being visualized.
Okay. I don't think that's. Let's take a look. I think I got the. Oh, I got this up for later. This is Angular source code. They're creating a string of JavaScript and then essentially using eval by passing it into a function constructor. They actually have to tell JSInt, I know this is evil, and let it happen. That's literally what this is doing. Pretty gross. But it just goes to show that even some of maybe the most popular JavaScript framework in the world, application framework, since I don't jQuery one of those, is in of itself sometimes does things that wouldn't be considered best practice. So we were looking at the digest. I don't think that's in here, is it? Nope. Yeah, it's probably an MG. I'm not disagreeing with you. Anyway, yeah, it is a root scope. That's it. Yep, there you go, buddy. Bar wash, or bar, do I have dirty? Yeah, bar dirty, right there. I agree. So again, this might fall into that category of things that Ingrid does that maybe you shouldn't, but just saying.
Just because they're pros of it.
Yeah, that's true. All right.
Well, it's a false value definition.
Yeah, yeah, that's true, right? You're right.
It's a false value, right?
Yeah, that's fair. All right, so I think one of the things we've shown here is that because it's kind of a recursive digest, that really speaks to the importance of limiting the number of watchers, especially dependent watchers, because you can force the digest cycle to iterate over all of your watchers again. And this gets really gross when you start talking about things like root scope that apply, which actually recursively executes the digest on all child scopes in the entire application. So even though you might be in an area of your app that's very isolated, under certain conditions you might end up causing some huge performance issues by having a lot of watchers in your app. So that is best practice number 4, I believe. Number 5, limit the number of watchers, limit dependency watchers especially. All right, so we did talk about an unstable digest, which is when you get that error 10 digest iterations for each boarding. So let's go ahead and handle that. We've got a test down here. I'll try and remember to keep things higher on the screen too. So we're expecting that our digest will give up on the watches after 10 iterations. So that number 10 is going to be hard-coded right now, but if you've ever worked with it in production Angular, root scope as a provider allows you to override that. So it's kind of an interesting thing. If you ever get in a situation where, for whatever reason, you know you need more than 10, you can. Don't know why you would. Basically, the determination there is, you know, hey, if our digest cycle has had to recursively call itself 10 times, and at the end of 10 times it's still dirty, you probably messed up would be the best way to say that. I had another word in my mind, but. All right. I mean, that could be a solution, potentially. You can turn it up to 11 and suddenly it works, and you just wash your hands, right? But Angular does allow you to do it. I'd like to say backbone gives you enough rope to hang yourself with, but there's a bit of rope in Angular sometimes. All right, 2 watchers, pretty simple. We're watching counter A, and when it changes, we increment counter B. We watch counter B. When it changes, increment counter A. Now, here's some chuckles. So, as you perhaps gleaned, this probably isn't a really good idea. And right now, if I were to run this, I'd have to shut down my server and probably restart Chrome. And so I'm not going to do that. What I'm going to do instead is actually go green refactor and not actually let this test fail, because I just don't want to deal with it. So the first thing we're going to do is create a TTL, which is what, again, is hard-coded, but Angular allows you to set that. And then we're just going to say in here that if we're still dirty, and we've essentially gone through 10 iterations, I'm going to throw an error. I especially love this when the production version will tell you this, and it'll show you like the watches that were run, and then if you're like the apps I've worked in, that's like 50,000 of them, and there's absolutely no value to that whatsoever. All right, so now if we save this, so that was Vault Notify, and
oh, did it turn off? Oh, my bad.
It's on like a 45.
Yeah, like doesn't pay attention to what that's actually like, and whether there's input or not. It just says like, turn me off.
Is that TTL is the
Yeah,
that's it.
TTL the TV.
Yeah. And I did actually have Vault Notify. I was yelling at me because I did something wrong.
You have a typo with it,
Yeah, you
I do.
Right,
I also have an extra
test, man.
Yeah, no kidding. What we got? Oh, yeah, so that's where that extra parentheses came from. It's kind of important. All right. Let me go back to here. Yay. So we're now running.
I don't believe it. How do we know you fixed anything? It was never read.
You can see it right there. Oh, you know what though? Yeah, did I actually? No. Yeah, I never did anything. You're right. That's a great call. What's funny is I ran through this like 5 times end to end in this talk, and I forgot this in every one of them. And I told myself I'm not going to do that, but and I got function right. It's good. So by wrapping this in an anonymous function, this will get executed and allow me to do things like this, rather than scope that digest with throwing error and not being able to move on. All right, so now, we can refresh just so that you know. Here, this is something down on the keyboard. We'll leave it up here. Incognito, so I don't think I have my plugins. I was going to include a cache too, but incognito, so I've already included a cache. All right. Okay, so in this implementation, oops, that's the right one. So we keep iterating over this collection. Again, I'm pointing with my hand, not my mouse. We keep iterating over this collection of watchers here. Every time at least one of them is dirty. And for very trivial apps, it's not that much of a problem. But if you have hundreds or thousands of watchers, and it's the first watcher that's dirty, you end up marking the whole cycle as dirty and then running it all over again on the next 1,000. So we are going to drop in one minor optimization that will say if there's 100 watches that are dirty and there are 100 watches in the array and it's the first one that's dirty, we're going to run the rest of this digest and then we'll run the subsequent digest only up until the last one that was dirty. And so we introduce a property called last dirty watch. And so I'll start with a test, which I almost didn't do. Good. And so I'm creating an array. I'm using Lodash just to create an array with the range from 0 to 100. It's 0 to 99 technically. And then I'm going to do another one. So we'll go to fix, paste. We're now using another helper function to essentially run this function here. 100. Whoa, yeah. I was going to say, so we run this function here 100 times. We're going to create 100 watchers, incrementing our watch executions integer that we find up here. And then we're going to digest. I want to take a stab on what watch executions is going to be after we digest. Keeping in mind that there are 100 watch functions. All right, everyone's shy. I'll give you one. 200. Because it's going to run one time, and the value is going to be essentially undefined. It's going to say, oh, hey, I'm dirty because I've not been updated. It's actually going to run again, which is why I said sometimes you'll get listener functions that'll get executed, or watch functions in this case, they'll get executed twice. Now, this is not part of the book, but I found this to be worthwhile as I was going through this. So listener executions equals 0. This is going to be 200. Ooh. And this is going to be 100. It's the first time you run through it. Every one of them is going to be marked as dirty, since again, the initial value is going to be different from that init watch val. So actually, if we run this by itself, this is going to not pass because it's not doing anything to it. That's a good reason for it to fail. All right, now this is going to pass. Where things get interesting though is if we update one. Now this is going to equal 101. This is going to equal 301. Now, by default, without having actually written the code to pass this, it's going to fail. It's going to expect 400 equals 301 because we haven't implemented that short circuit operation to say, hey, I only want to run that subsequent digest until I hit the last one that I was on. That was dirty. So why don't I just implement this, and then we'll come back and talk about it maybe a little bit. It's actually fairly simple, but maybe one of the more complex things we've done. First thing we're going to do is add this last dirty watch. We'll initialize this one. And every time we run a full digest, not just a digest loop, right? So that's what digest 1 is doing. It's just kind of a single digest loop. But every time we execute the full digest itself, which will then subsequently execute potentially several digests. Oops. That was not very long. We'll set this to no. And then inside of our digest once function, we're going to go ahead and assign it. So every time we get a new dirty watch, we're going to go ahead and assign that watcher to the last dirty watch property. And then, so as we're going through, this is now getting to kind of that. So as we go through here, last dirty watch is basically going to be everything, since they're all dirty. But where it gets interesting is when we get down here and we update it. So if you think about, like, logically step through what's happening here, we're updating the first value and we're executing a digest. So this dot watchers up in line 23 is going to be a 100-item array. The first watcher happens to be the one that's dirty, which means the first watcher is the only one that's going to set itself that last dirty watch. Because we're inside of the dirty function, dirty is going to set to true, which is going to force us to pick off a subsequent digest or iteration of the watchers. And now the first one we get to, new value is going to be equal to old value because it hasn't changed since the last time. And this is where we're going to add the short circuit. So since it's not dirty, we want to say, well, what if self that last dirty watch is equal to our watcher? That's how we know the last dirty watch we assigned up on line 27 is now the watch that we're on the subsequent digest. So we can return false, which in Lodash is for each. If you return false, it just immediately executes, short circuits the loop and executes exits immediately. And so because of this, dirty is never going to be assigned in here, and this is probably why, actually, now I think about it. So dirty never gets set, which means dirty is now falsy, and so line 49 exits the while loop. I'm going to save that. Oops. Okay. There we go. All right, so now this is that short circuit operation that has allowed us to optimize the code a little bit. Okay. Double check and make sure I didn't miss anything. It's kind of flying around there. Good. So now we have a digest cycle that's at least potentially a little faster than it was before. But again, I'm going to beat a dead horse, sound like a broken record, etc. Having a lot of watch functions, having expensive watch functions is probably the single worst thing you can do for performance in Angular. So pay very close attention if you have performance issues. Almost certainly it's digest related. There is a bit of an edge case to handle here, which I've never experienced myself, again, in production code, but it could happen, so we're going to account for it. And that is if you have a digest that has a new watcher registered as part of the listener function. So inside of the listener function, you're actually, no, I have seen that now that I think about it. Inside of the listener function, I can write it. Somebody creates somebody creates a watch function. Currently, with this new short circuit operation, that'll never run, and I'll demonstrate why momentarily. So here's the use case. We've got a watch function. So line 79 here, let me help you out here. Line 179, I'm sorry. We're watching model.a value, currently set to ABC. And then in our listener function, we're registering a new watch. And this watch is watching the same property, and then it's incrementing our counter. So if we save this and check out our trusty, oh, again, I need to actually, yep. Just so excited. So now if we run this, it's going to fail. So that second watch is not being executed. And so let's take a quick peek at why that might be happening. So the first time we go through the watchers array, which there's only one, we notice that the value here is technically dirty because, again, we have the init watch val. So we call the listener function the first time. The listener function here ultimately gets called because it's dirty, and that registers the second watcher. But the first time we iterated through this .watchers, there was only one item in the array, and it was the first watcher. So then we did mark dirty as true. We came down into here, we saw dirty was true, we kicked off another digest, but then it gets up to here and it says, well, hey, I got to the first item in my watchers array, and that happened to be my last dirty watch, so I'm going to return false, and it never gets to the second watcher. So very simple fix for this is, anytime we add a new item to our watchers array, we essentially disable this optimization on that particular digest. And now our test passes. All right, how am I doing on time?
We have 5 minutes left.
Okay.
What were we shooting for?
8:20. Yeah. So we can do prizes and yeah.
All right. So up to this point, we've only been doing basic reference quality. So using the not equal symbol there. And this is great if you're watching numbers and strings, or even objects if you're going to assign a brand new object to an object variable. But it doesn't do anything if we actually have properties on an object or items in an array that change. And so this is where we get into the deep equality checking, or value-based dirty checking is another term for it. And that's where that third parameter of the watch function comes in. So if you've done any sort of deep checking before, you're familiar with this. So I'm going to zoom a little bit here and not type as much. Mostly that guy that made me look up whether or not I should initialize dirty. Just kidding that. All right. So we've got a value on our model, which is an array. We've then got our normal listener function of the counter. Here's that third property true. When we digest, we expect that our counter is going to be incremented and it'll be equal to 1. If we push a new value into our array, we digest again, we're expecting our counter to be 2. We look at our test, we expect 1 to be 2. Why is that? It's because we're not deep checking in our comparison. So, watch function, the value equality. If you haven't seen the double bang syntax, that just does Boolean type conversion, type coercion. I won't really get into why. Look it up though, it's kind of cool. And so just as a quick recap, what we're going for here is a full recursion of all properties nested otherwise in an object. Then all items either at the top level of the array or nested. This is another use case for where angular.equals is not being implemented, so we can do flow dash. Oops, that's not right. So he's checking that for the listener functions. I'm just going to say if our value-based dirty checking flag is true, we use underscore dot is equals is the same as angular dot equals. Just check to see if those two objects / arrays, whatever, are equal. Otherwise, we'll just use standard directory checking. And that will require us to update a couple of things. So first, our check here is going to be, oops. Now we're going to go ahead and pass in the new value, the old value, and then that third parameter. And then kind of the last thing with this is right now, because we're setting watch got last to new value, and this is by reference. If we update anything in watch got last, for example, it's going to update the reference as well. So this is where we're also going to do, if this is a, if that third parameter is true, we're going to do a heap clone, copy. Otherwise, we're just going to set it to new value. I think this should pass our test. It does. What else do I have? So I'm not going to handle a lot of numbers for my time. So I've got two more. That shouldn't take too long. So the last thing really to implement is scope.apply, which is actually quite trivial. Before I can do that, though, I need to introduce scope.eval, which is ultimately what scope.apply calls. So all eval is a way to evaluate code in the context of scope and actually execute a function. And so let's toggle over here. Yeah, whatever, doesn't handle that numbers up here. There's two tests that we are concerned with here. And we've got the scope apply, and that's it. So 3 more tests. All right. So the first thing with eval is that we're expecting it to execute an eval function and return a result. So var result equals, oops. So eval, the first parameter is scope, and we'll actually get to a second optional parameter in the next test. All we're expecting is result to equal 42. This is going to be a very complicated way to call a function, and I'll explain why in a second. So the biggest gain or win that you get with eval is actually when we get to expressions, which we're not going to handle today. So there's the second optional, which we'll add a second in a test. So all we're doing is taking the function that gets passed in, executing that function, passing in scope, and then whatever optional second parameter might get passed in. That's it. And so again, we're kind of calling a function to call a function. So this test will now pass, I believe, yep. And then the next one just says the second parameter in the eval, which is the second parameter is actually down here. So the first one is the function, and the second parameter. So we're just confirming that this gets passed through. So all we're saying is if we call eval with the second parameter, in this case number 2, that'll just get passed into this function, ultimately get executed, and our test passes. So I'd probably spend a little bit more time on eval if I had it, but as I said, it's probably more about the author says that one argument is that it's slightly more explicit that we're dealing with scope, and I guess I can agree with that. More importantly, it is a building block for apply. Probably most importantly, when you want to do things like in a directive, perhaps. I know I've done this. They've got an adder called, I don't know, my adder. Or if you want to eval that in context of scope, that's where you might see that. So that's where its primary use case is. But lastly, then we'll implement apply. And this is way, way, way simpler than I thought it would be. That's it. That's everything that there is to apply. So the thing to talk about with apply, So apply is most commonly used to integrate third-party libraries in Angular. And the thing about third-party libraries is they have no concept of Angular. They have no concept of digest or dirty checking or two-way data binding. And so why we use eval is, again, we're executing this function within the context of scope by passing the scope variable in here. And so any changes we make, I didn't write the test profile for that. Any changes we make that's wrapped inside of apply will get added to the scope, and then because scope, even if this errors out, because scope will always call a digest cycle afterwards, that's how Angular is now aware of the changes that your third-party library might have added to scope. So let's check that test. Let's do this. Let's copy this and add it over. That's about it, right? Yeah. Good job. All right, so we've got a watcher, standard watcher, model.a value. Let's increment our counter. Let's run a digest. Check to make sure our counter is 1. Now let's do something cool. Call scope.apply. Inside of that, call scope.model.a value, or not call, but set scope.model.a value to something new. And expect our counter to increment. So that's kind of a closing. I think we'll walk through that rabbit hole a little bit. So when apply is called, we're delegating all the functionality basically to eval. Eval is just executing the expression and passing in scope as the first argument. And then, as I said, because we're calling digest for us, the digest cycle then picks up that a value was changed. Now, keep in mind this is not being handled by third-party code, but if it was, this value might be set by to some arbitrary data chunk that's coming back from your third-party API. And then by running digest, digest will pick up the fact that scope.a value is no longer some value, it's now some other value. And that's why if I'm all saved, not pass. So with that, that is, I know it's a simplistic implementation at this point, but we have a perfectly usable implementation of Angular style dirty checking. So we've covered watch and digest, dirty checking loop, reference-based versus value-based comparisons. There's a really cool slide that I wish I had time to get to. I'll just pull it up and solve the time. That shows reference-based checking, equality-based checking, and then collection watches, which I haven't really used a whole lot of. And this is really interesting. If you add items to an array, remove them, reorder them, add or remove properties from an object, it's a much lighter weight equality check than this guy. So it's another useful one that I wanted to implement today. As far as speakers, if you guys like this, let us know or let me know. There's 15, 18 chapters in this stuff. Everything from the next chapter is scope inheritance, which is really cool, creating isolate scopes and things like that. I have to give more options at any time, or if people want to hang out and hack on this. So this has been a lot of fun. So that's all I got. Any questions? Once we go.
Thank you very much, Scott.
No.
Okay, so normally what we do at the end here is we do a raffle. We have some cool sponsors for raffle prizes. DipRains, which creates the WebStorm IDE along with other IDE products for various languages, which are listed down here. Give away a license to one of their products every month to one of our members. Front-End Masters, which is run by a local guy called Mark Gravansky. It's a training site where he brings in people to do workshops, and then they do videos and record them for subscribers to check out later. So we have one year subscription to that, and a 1 month subscription to Pluralsight, which they provided us with a bunch of cards for that. So grab my laptop. And we have Dale to thank, Dale Lotz, for our lovely
prize randomizer generator. It pulls all of the attendee lists from Meetup and lets us pick random winners. So we wanted me to point out that the About page has a lovely donate link for PayPal. So if you win something, you can thank Dale for that way.
I'll send you Dogecoin.
Right, whatever.
So our first winner is Joshua Strethsla. Yes. Okay, you have your pick. What would you like? Throw site? Okay, we'll get to the card. Actually, John, you want to get that right now? Yes. I forgot to bring them in.
Need a round. Walk like a fast.
All right. Our next winner is Cal.
Go
Go up. Sorry.
I'll take JetBrains.
JetBrains. All right. Which one would you like?
Intel J.
Intelligent. Sweet.
Climb all day. I need more, yeah!
That's why I had to click save and wait
Somebody I know calls it.
for you.
Somebody I know calls it.
So our front-end masters winner then will be Jason. Congratulations, Jason.
Rick. Hey,
Sources on GitHub.
We didn't write this.
That's all I got. Feel free to mingle for a little bit while we tear down. If you are sitting on a chair with legs, we would kindly appreciate that you bring it to the kitchen so that it's less things for us to move. Otherwise, have a great night. Thanks for coming.
Oh, Jason won. Nice.
All right,